It is a well-known fact that self-sufficiency in food has been achieved in India since late 20th century by using fertilizers and pesticides and exploring improved methods of farming, good quality seeds, irrigation, etc. But our exploitation of soil and excessive use of fertilizers and pesticides have resulted in the deterioration of soil and water. The solution of this problem does not lie in stopping the process of development that has been set in, but to discover methods which would help in the reduction of deterioration of the environment. Green chemistry is a way of thinking and is about utilizing the existing knowledge and principles of chemistry and other sciences to reduce the adverse impact on environment. Green chemistry is a production process that would bring about minimum pollution or deterioration to the environment. The byproducts generated during a process, if not used gainfully, add to the environmental pollution. Such processes are not only environmental unfriendly but also cost ineffective. The waste generation and its dispose both are economically unsound. Utilization of existing knowledge base for reducing the chemical hazards along with the developmental activities in the foundation of green chemistry. It is well known that organic solvents such as benzene, toluene, carbon tetrachloride, etc. are highly toxic. One should be careful while using them. As you know, a chemical reaction involves reactants attacking reagents and the medium in which the reaction takes place. Extent of a reaction depends upon physical parameters like temperature, pressure and use of catalyst. In a chemical reaction, if reactants are fully converted into useful environmental friendly medium, then there would be no chemical pollutants introduced in the environment. During a synthesis, care must be taken to choose starting materials that can be converted into end products with yield approximately up to 100%. This can be achieved by arriving at optimum conditions of synthesis. It may be worthwhile to carry out synthetic reactions in aqueous medium since water has high specific heat and low volatility. Water is a cost-effective, non-inflammable and devoid of any carcinogenic effects. Green chemistry is a design of chemical products and process that reduce or eliminate the use of generation of hazardous substances. Green chemistry is a design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. Green chemistry applies across the life cycle of a chemical product, including its design, manufacture, use and ultimate disposal. Green chemistry is also known as sustainable chemistry. Green chemistry prevents pollution at the molecular level. It is a philosophy that applies to all areas of chemistry, not a single discipline of chemistry. Applies innovative scientific solutions to real-world environmental problems. Results in source reduction because it prevents the generation of pollution. Reduces the negative impacts of chemical products and process on human health and the environment. Lessens and sometimes eliminates hazards from existing products and process. Designs chemical products and process to reduce their intrinsic hazards. How green chemistry differs from cleaning up pollution? Green chemistry reduces pollution at its source by minimizing or eliminating the hazards of chemical feedstocks, reagents, solvents and products. This is unlike cleaning up pollution, also called remediation, which involves treating waste streams and of the pipe treatment or cleanup of environmental spills and other releases. Remediation may include separating hazardous chemical from other materials, then treating them so they are no longer hazardous, or concentrating them for safe disposal. Most remediation activities do not involve green chemistry. Remediation removes hazardous materials from the environment. On the other hand, green chemistry keeps the hazardous materials out of the environment in the first place. If a technology reduces or eliminates the hazardous chemicals used to clean up environmental contaminants, this technology would qualify as a green chemistry technology. One example is used to capture mercury from the air for safe disposal with an effective but non-hazardous sorbent. Using the non-hazardous sorbent means that the hazardous sorbent is never manufactured, and so the remediation technology meets the definition of green chemistry. Now we will discuss about some important environmental laws. The need for protection and conservation of environmental and sustainable use of natural resources is reflected in the constitutional framework of India and also in the international commitment of India. The Constitution under Part 4A, Article 51A, fundamental duties casts a duty on every citizen of India to protect and improve the natural environment, including forests, lakes, rivers and wildlife, and to have compensation for living creatures. Further, the Constitution of India under Part 4, Article 48A, Directive Principles of State Policies, stipulates that the state shall endeavour to protect and improve the environment and to safeguard the forests and wildlife of the country. Several environment protection legislations existed even before independence of India. However, the true thrust for putting in force a well-developed framework came only after the UN Conference on the Human Environment, Stockholm, 1972. After the Stockholm Conference, the National Council for Environmental Policy and Planning was set up in 1972 within the Department of Science and Technology to establish a regulatory body to look after the environment-related issues. This council later evolved into a full-fledged Ministry of Environment and Forest, MOEF. MOEF was established in 1985, which today is the apex administrative body in the country for regulating and ensuring environmental protection and lays down the legal and regulatory framework for the same. Since the 1970, a number of environment legislations have been put in place. The MOEF and the Pollution Control Board, CPCB, that is Central Pollution Control Board, and SPCBS, that is State Pollution Control Board, together from the regulatory and administrative core of the sector. Some of the important legislations for environmental protection are, we can discuss on these important legislations for environmental protection. First, the National Green Tribunal Act 2010, the Air Prevention and Control of Pollution Act 1981, the Water Protection and Control of Pollution Act 1974, the Environment Protection Act 1986, and the Hazardous Waste Management Regulations, etc. First, we will discuss on the National Green Tribunal Act 2010. The National Green Tribunal Act 2010, number 19 of 2010, NGT Act, has been enacted with the objectives to provide for establishment of a National Green Tribunal, NGT, for the effective and expeditious disposal of cases relating to environment protection and conservation of forests and other natural resources, including enforcement of any legal right relating to environment and giving relief and compensation for damages to persons and property and for matters connected therewith or incidental thereto. The Act received the assent of the President of India on June 2, 2010 and was enforced by the Central Government by notification number SO2569E dated October 18, 2010 with effect from October 18, 2010. The Act envisages establishment of NGD in order to deal with all environmental laws relating to air and water pollution. The Environment Protection Act, the Forest Conservation Act and the Biodiversity Act have been set out in Schedule 1st of the NGT Act. Consequent to enforcement of the National Green Act 2010, the National Environmental Applicable Authority Act 1997 stands repealed. The National Environment Affiliate Authority Act 1997 stands repealed. The National Environment Affiliate Authority established under 531 of the National Environment Affiliate Authority Act 1997 stand dissolved in view of the establishment of the National Green Tribunal under the National Green Tribunal Act 2010. Wide notification number SO2570E dated October 18, 2010. Second Act, the Air Act, the Air Prevention and Control of Pollution Act 1981. The Air Prevention and Control of Pollution Act 1981. The Air Act is an act to provide for the prevention, control and abatement of air pollution and for the establishment of boards at the central and states levels with a view of carrying out this purpose, aforesaid purpose. To counter the problems associated with air pollution, ambient air quality standards were established under the Air Act. The Air Act seeks to combat air pollution by prohibiting the use of polluting fuels and substances as well as by regulating appliances that give rise to air pollution. The Air Act empowers the state government after consultation with the SPCs to declare any area or areas within the state as air pollution control area or areas. Under the Act establishing or operating any industrial plant in the pollution control area requires consent from SPCs. SPCBs are also expected to test the air in air pollution control areas, inspect pollution control equipments and manufacturing processes. Third, the Environment Protection Act 1986. The Environment Protection Act 1986, the Environment Act provides for the protection and improvement of environment. The Environment Protection Act established the framework for studying, planning and implementing long-term requirement of environmental safety and laying down a system of speedy and adequate response to situations threatening the environment. It is an umbrella legislation designed to provide a framework for the coordination of central and state authorities established under the Water Act 1974 and the Air Act. The term environment is understood in a wide term under Section 29 of the Environment Act. It includes water, air and land as well as the interrelationship which exists between water, air and land and human beings, other living creatures, plants, microorganisms and property. Under the Environment Act, the central government is empowered to take measures necessary to protect and improve the quality of environment by setting standards for emissions and discharges of pollution in the atmosphere by any person carrying on an industry or activity, regulating the location of industries, management of hazardous wastes and protection of public health and welfare. From time to time, The central government issues notifications under the Environment Act for the protection of ecologically sensitive areas or issues guidelines for matters under the Environment Act. In case of any compliance or contravention of the Environment Act or the rules of directions under the said Act, the violator will be punishable with imprisonment up to 5 years or with fine up to rupees 1 lakh or with both. In case of continuation of such violation, an additional fine of up to 5,000 for every day during which such failure or contravention continues. After the conviction for the first such failure or contravention will be liable. Further, if the violation continues beyond a period of 1 year after the date of conviction, the offender shall be punishable with imprisonment for a term which may extend to 7 years. Hazardous waste management regulation. Hazardous waste means any waste which by reason of any of its physical, chemical, reactive, toxic, flammable, explosive or corrosive characteristics cause danger or is like to cause danger to health or environment, whether alone or when in contact with other wastes or substances. There are several legislations that directly or indirectly deal with hazardous waste management. The relevant legislations are the Factories Act 1948, the Public Liability Insurance Act 1991, the National Environment Tribunal Act 1995 and rules and notification under the Environment Act. Some of the rules dealing with hazardous waste management, handling and transboundary rules 2008 brought out a guide for manufacture, storage and import of hazardous wastes. Biomedical waste management and handling rules 1998 were formulated along parallel lines for proper disposal, segregation, transport, etc. of infectious waste. Municipal solid waste management and handling rules 2000 aim at enabling municipalities to dispose municipal solid waste in a scientific manner. In view of the shortcomings and overcoming of some categories causing inconvenience in implementation of the biomedical waste management and handling rules 1998 as well as the municipal solid waste management and handling rules 2015 draft BMW rules and the draft solid waste management rules 2015 draft SWM rules and sought comments on the draft rules. Pollution Prevention Act of 1990 to stop creating pollution in the first place became Americans' official policy in 1990 with the Federal Pollution Prevention Act. The law defines source of reduction as may practice that. First, reduces the amount of any hazardous substance, pollutant or contaminant entering any waste stream or otherwise released into the environment including fugitive emissions prior to recycling, treatment or disposal. Second, reduces the hazardous to public health and the environment associated with the release of such substance, pollutants or contaminants. The term source reduction includes modifications to equipment to technology, modifications to process or procedures, modifications, reformulation or redesign of products, substitution of raw materials, improvements in housekeeping, maintenance, training or inventory control. Section 2 of the Pollution Prevention Act establishes a pollution prevention hierarchy saying, the Congress hereby declares it to be the national policy of the United States that pollution should be prevented or reduced at the source whenever feasible. Pollution that cannot be prevented should be recycled in an environmentally safe manner whenever feasible. Pollution that cannot be prevented or recycled should be treated in an environmentally safe manner whenever feasible. Disposal or other release into the environment should be employed only as a last resort and should be conducted in an environmentally safe manner. Emergence of green chemistry. Now we know about emergence of green chemistry. The idea of green chemistry was initially developed as a response to the Pollution Prevention Act of 1990, which declared that US national policy should eliminate pollution by improved design, including cost-effective changes in products, process, use of raw materials and recycling, instead of treatment and disposal. Although the US Environmental Protection Agency (EPA) is known as a regulatory agency, it moved away from the command and control or end-of-pipe approach in implementing what would eventually be called its green chemistry program. By 1991, the EPA Office of Pollution Prevention and Toxics had launched a research grant program encouraging redesign of existing chemical products and process to reduce impacts on human health and the environment. The EPA, in partnership with the US National Science Foundation (NSF), then proceeds to fund basic research in green chemistry in the early 1990s. The introduction of the annual Presidential Green Chemistry Challenge Awards in 1996 drew attention to both academic and industrial green chemistry success stories. The awards program and the technologies in highlights are now a cornerstone of the green chemistry educational curriculum. The mid to late 1990 saw an increase in the number of international meetings devoted to green chemistry, such as Godson Research Conference on Green Chemistry and Green Chemistry networks developed in the United States, the United Kingdom, Spain and Italy. The 12 principles of green chemistry were published in 1998, providing the new field with a clear set of guidelines for further development. 1. In 1990, the Royal Society of Chemistry launched its journal Green Chemistry. In the last 10 years, national networks have proliferated. Special issues devoted to green chemistry have appeared in major journals, and green chemistry concepts have continued to gain traction. A clear sign of this was provided by the citation for the 2005 Nobel Prize to Chemistry awarded to Chauvin, Grubbs and Anschrock, which commented their work as a great step forward for green chemistry.